string search algorithm. Maybe we can also use the same string, a lot of zeros. And now let's think about what might be a worst case scenario pattern such that we can maximize the number of comparisons. So this is a string we have, and I think I think we already got a suggestion from Yang Jie from the chat window a couple 15 minutes ago, and the suggestion is that if we have a pattern of if we have a string of repeated A's, and then the pattern might be BAAA. And to convert it into our case, I think we may have a pattern like 10000. And I agree with this idea because now what we have is, remember we start comparing from the end of the pattern. And since the string contains all zeros, we're going to make a successful comparison, 2 successful comparisons, 3 successful comparisons until we reach the beginning of the pattern. And suppose that our pattern has a length of m, then we will need to make m comparisons before we can move the pattern, right? We make m comparisons and the last comparison giving us a mismatch, then we move the pattern. And after moving the pattern, I think we're going to have another m number of comparisons. This will be repeated until we have our pattern moved to the end of the string. And that will give us the last m comparisons before we can say that we cannot find this pattern in the string. And if you try to count the number of m's here, let's say the length of the string is n, then we're going to have that many number of comparisons. And if you compare with the conclusion we find when we talk about brute force string search algorithm, you'll find exactly the same result. So in the worst case, the horsespool search string search algorithm will have the same complexity as the worst case scenario in brute force string search algorithm. And if you still remember the worst case scenario, I think the complexity is n to the power of 2. But the idea is that, as we can see from today's discussion, by using horsespool string search algorithm, it's possible that in some cases, we're going to move for more than 1 positions rather than just move for 1 position. And for the average case, the horsespool string search algorithm will have a time complexity of n. So it's a linear time string search algorithm. It's out of the scope of our subject to prove that the average case is in linear time. But if you are interested, I think you can freely go through the textbook or you can search online. There are several different ways of proving that the horsespool string search algorithm has an average case ON time complexity. Now for the worst case, well, we've already constructed a worst case scenario, and for coming up with n to the power of 2, that's exactly the same idea as we had in past weeks for brute force string search algorithm. We'll quickly move on to the hashing